All right. So I know yesterday's mesmerizing lesson about probability left a little bit to be desired, but here is going to be the one that drives the proverbial nail home. So if you take out your notes under probability, here is going to be we're just going to briefly talk about this for a second. Okay, I mentioned to you that there's two things. There is theoretical, or somebody help me with that, or ethical, and experimental. And you are going to help me either prove or disprove this. If I'm wrong, I will color it in whatever here. Okay. Theoretical is mathematically what should happen. We had this problem. Mathematically, what should happen. And experimental is what actually happens when you do it. You have this written down. This should not be something new. Now, in order for you, and I made this point just as you left yesterday, and I said, I'm going to try and prove this to you. All right. Not always, theoretically doesn't always happen. For example, if I had a deck of cards, and I said, what's the probability of drawing an ace out of the deck of cards? Well, probability of an ace, there's 52 cards. How many of them are aces? 4, which gives you 1 in 13. Okay, that means if I went around the room here and had you blindly pick a card, 1 out of every 13 times you should get an ace. Which would mean out of you, there's like almost 20, because you should get 2 aces. Will that happen? No. The first 2 people might draw an ace. Okay? Theoretical probability that it doesn't always happen. But I told you this, I said, as you continue, if I were to walk around this room for like 7 days and keep track of how many aces were pulled out of the thing, the theoretical probability and the experimental probability will merge together miraculously, because in the end it always works out. Hence the reason why the lottery makes people money. Okay? The reason why the lottery works is because eventually all the numbers always work out. Same thing by going to the casino. Yes, somebody's going to win $1 bazillion, okay? But there's also going to be a lot of somebodies that lose everything they possibly possess. And that's why lotteries work. You know, yeah, there was a 1-point-some billion, but they don't tell you about all the people that spend thousands of dollars a year and they never win anything, or they win something fiddly. So here is going to be our experiment. First of all, how many people are there here today? Wow. Wait, is that all you have?
Yeah.
Okay. All right. Let's think theoretically here. Okay. I'm going to have you flip a coin. Don't touch it yet. Joseph, did you touch it?
No, I did not.
All right. The probability of you, and we're going to count how many heads you flip. Probability of flipping a head is what? 1/2, right? There's 1 head out of 2 sides of the coin. It should be a fair coin. Okay? You are going to individually each flip your proverbial penny when I tell you 10 times. Okay? Which means, if the probability is 1/2, theoretically, you should get 5 heads and 5 tails, right? 5 heads, 5 tails. Now, we are going to check and see. I would bet most of the time that isn't true. You'll get 6 heads or whatever. But then, in the end, we're going to pretend like we've done it a bunch of times. We're going to put all of yours together, which means we did it a lot more times. And we're going to see how close actually, because that would be 10 times 220, we should get 110 heads. Theoretically, but experimentally, as you do it more, I told you it'll get closer and closer to what it should be. And hopefully this will prove it. I could be way wrong. I could just be lying to you, but I don't think so. In the end, it'll work out kind of in the end. I hope it gets close here. Are you with me? Some of you, by the way, probably will get like 8 heads, which theoretically is, it's just the way it works. But the more you do it, the more it's actually going to happen. So on your little piece of paper there, I want you to write a little H and a little T so you can keep track, and I don't want you to do it in your head. But on your paper go H and T, and I want you to do it 10 times, and I want you to mark down how many heads and how many tails you get. On your mark, get set. Well, if you were here, Sophia, you would have a penny. Go! It's a race to see who gets done first. Really, you shouldn't have to fall. They shouldn't fall on the floor. How hard is this? Oh, just drop it somewhere random. There. Are we done there? Again, going back to the theoretical and the experimental. Theoretically, how many people actually got 5 heads, 5 tails? All right, take a look. Out of all of you, I can't change that, Zach. Like 1, 2, 3, 4, 5, 6, 7 of you. Really, theoretically, everybody should have. Because that's the theoretical. Okay, but it doesn't happen theoretically. Now, as we go, I mean, when we do all 22 of you, we've now done it 22 times more, and those percentages should really come very close in the end to 50%, because eventually, theoretical and experimental will collapse. So when I ask you, you need to tell me how many heads, how many tails, and we will see at the end if all of this combines into one glorious. And if it ends up being exactly 110, you will all say, Mr. Nine, you are the absolute bomb. No, you're not best teacher, something like that. I can tell you, really, the odds of it actually being 110, pretty iffy. But I'm going to guess we're going to get within 3 or 4 either way, I hope. Otherwise, it's a bust. You can say bomb or bust. So here we go. Starting at the back of the room, Emily, what'd you get for heads?
6.
1, 2, 3, 4, 5, 6. And tails, you must have got, well, I guess we don't have to keep track of heads, right? Because we know everything else was tails. So let's not do tails. Let's just do heads. All right, Chase.
7 heads.
How many?
7.
1, 2, 3, 4, 5, 6, 7. Emma.
5.
1, 2, 3, 4, 5. Lauren.
5.
1, 2, 3, 4, 5. Kaylee. See, he's going to be the guy that cancels us out yet. Madison.
5.
1, 2, 3, 4, 5. Joseph.
5.
1, 2, 3, 4, 5.
6.
1, 2, 3, 4, 5, 6.
5.
1, 2, 3, 4, 5. Uh-oh. Uh-oh. I need a couple low numbers here just to balance this out, or it's never going. Cassie.
3.
Thank you. 3.
5.
1, 2, 3, 4, 5.
3.
Oh, there's my 3. Good. Autumn.
6.
There's my canceling out. 1, 2, 3, 4, 5, 6. Sergey.
4.
Ooh, 1, 2, 3, 4. Con.
7.
Maybe I should go to a different section here. 1, 2, 3, 4, 5, 6, 7.
5.
1, 2, 3, 4, 5. Aaron.
8.
1, 2, 3, 4, 5, 6, 7, 8. Zach.
And 4.
Good. 1, 2, 3, 4. You help me out with that. Gianna.
6.
1, 2, 3, 4, 5, 6.
3.
1, 2, 3. 1, 2, 3. 1, 2, 3, 4, 5. So we did it 220 times, right? I got everybody? Somebody already has this calculated here. 10, 20, 30, 40, 50, 60, 70, 80, 90, 109 times.
No. You were the bomb, Mr. Hahn.
Thank you, Zachary. It may not have worked that way, but I can tell you if we did it all 10 more times,
Let's do it.
we probably would get even closer still. The more you do it, the more it's just, Because that's the probability. That's the theory of it all. The math will eventually go. Now, those of you that got like 8 heads, you're like, well, that doesn't work out. But that's just because you didn't do it enough times for it to work out. Guarantee, if given enough time, these 2 percentages or whatever, you're going to get to that 50% of the time. Which maybe a coin is not fair. Did you ever think about that?
Yeah.
Did you ever think about maybe the head side weighs a little bit more than the other? It's not completely balanced. Or maybe the head shows up 1 extra time or 1 fewer times every whatever. I mean, maybe this isn't perfectly fair. Somebody should do some sort of an experiment on that. Flip it 1,000,000 times and see if you actually come up with 500,000 times.
What about like 100?
So, ladies and gentlemen, that, as they say, I'm a happy person because it actually